In this lesson, we'll talk about the quotient rule. As with the product rule, the quotient rule is used in a specific case of derivatives. Where the product rule you use every time you see a product of two functions, the quotient rule generally is used every time you see a quotient of two functions, or perhaps even a fraction of two functions is a way that you could think about it. Now I will highlight this formula here. However, just like I did with the product rule, I'm more interested in using words every single time I do one of these problems. And so here are my words. You take the derivative of the top times the bottom, minus, slightly different from the product rule, minus the derivative of the bottom times the top. And then we have this all over the bottom squared. So the quotient rule takes a problem that was a quotient and changes it to its derivative, which is again another quotient. So let me point out also that you really don't have to use the quotient rule at all. If you're good at changing quotients to products and then using the chain rule, you actually never have to know the quotient rule. So it's up to you if you really want to use it. However, for our purposes, let's use the quotient rule for all of our examples here. Let's take the derivative of this expression. We call this thing y prime, as usual. And so we take the derivative of the top times the bottom minus the derivative of the bottom times the top. And again, every time I do these problems, I go ahead and put in the derivative notation, but don't calculate the derivatives yet. All over the bottom squared. So then let's calculate our derivatives. The derivative of 3x squared is 6x. And then we have the x cubed minus 1. The derivative of x cubed minus 1 is 3x squared. And then we also have the other 3x squared. Put it over this same denominator. And while I could simplify this, I'm just going to go ahead and stop here. This will be my final answer. Next example. Now, this is a place where I would not use the quotient rule. And this is why. I have a number in the numerator. And when I take the derivative of the top, I'm just going to get 0. That's a bit of a waste of time to do. So a better way to solve the problem if you see a number in the numerator is to rewrite it. I'll just rewrite this as 1 plus e to the x to the negative 1 power. Now that should be pretty helpful. If I just solve this problem by chain rule, I have the answer immediately. However, if you really want to use the quotient rule, you're welcome to. Just keep in mind that the derivative of 1 is 0. But every time I see a number, I would just leave the number in front, even though there's nothing written here this time, and rewrite the denominator with the appropriate power. Anyway, let's use the chain rule. I'm going to think of this like u to the negative 1. And so the derivative of u to the negative 1 would be negative 1 in front. U is 1 plus e to the x. Remember, leave the inside alone. And then subtract 1 from my power to get negative 2. Times the derivative of the inside. So let's just write this as negative 1 plus e to the x to the negative 2. And the derivative of 1 plus e to the x is e to the x. So even though this problem appeared to look like a quotient rule, the chain rule was the fastest way to do this one. Let's do one more. Remember, the derivative of the top times the bottom minus the derivative of the bottom times the top, all over the bottom squared. Now this is pretty easy to take these derivatives. The derivative of e to the x is e to the x. And then I keep my x squared. The derivative of x squared is 2x. And I'll keep my e to the x. And because it's simple, let's go ahead and write x squared squared as x to the 4th. Now just like when I use the product rule with e to the x, sometimes I like to factor out e to the x. So I'm going to say e to the x times x squared minus 2x over x to the 4th. And that will be my final answer.